Sec 3 NA Chapter 4 Congruency and Similarity Part 1. In this part of the chapter, we are going to look at some similar figures. What are similar figures? Similar figures are shapes, which have the same shape, but they are different in sizes. Some can be small, some can be big. Now, in similar figures, all the corresponding angles are equal, and the ratio of all the corresponding sides, the ratio are equal. So for example, if I have a small triangle and a big triangle, the ratio of one of the sides is 2:3. That means all the other corresponding sides will also have a ratio of 2:3. Now let's take a look at the following diagram over here. We have with us a trapezium A, B, C, D. Now, if this is the original size of a trapezium and it were to become a larger trapezium where it's A prime, B prime, C prime, D prime. So I have my original one, A, B, C, D, and now it matches with A prime, B with B prime, C with C prime, and D with D prime. So it now becomes a bigger image. So this means from small, I change to become big, I will have an enlargement. Now, scale factor of an enlargement is given by the length of the image over the length of the original. So in this case, if I were to have an enlargement, the scale factor can be given by taking the image, which is the big, over the original, which is the small shape. So scale factor for enlargement will be big over small. Now, if I were to have the original shape A, B, C, D, instead of it becoming bigger, there is a reduction. It shrinks and become a smaller size. So for example, if I get A double prime, B double prime, C double prime, and D double prime. So in this case, I will have from the original a bigger image. It becomes a smaller image. Okay, so when in this case of a reduction, the scale factor is given by the length of the image, which is the smaller length, divided by the length of the original, which is a slightly bigger length. So in this case, for a reduction, if we were to have a reduction, the scale factor will be taking the image, which is the small, over the original, which is the bigger one. Okay, so when there is a reduction, the scale factor is given by taking the length of the small over the length of the bigger one. Now let's take a look at some of the following examples over here. What are some of the corresponding lengths for the original and the enlarged figure? This is 6 and this is 12. The corresponding sides have a measurement of 6 and 12. So to find this scale factor here, it will now be taking the image of the bigger one, which is 12, the length of the bigger one, divided by my original, which is 6. Hence, the scale factor will be the number 2. Now let's take a look at the smaller, the reduction image. So if I have AB to be 6, and now A double prime and B double prime becomes 3, how do we find the scale factor? Now that means the scale factor will become taking the length of the image, which is the small one, 3 over the bigger one, 6, which is 1 over 2. So this is how we calculate scale factors. Some interesting things to take note. If you were to have an enlargement, for an enlargement, the scale factor itself will be something that is becoming larger. So if I were to have an enlargement, the picture makes it becomes bigger, the scale factor becomes larger, therefore the scale factor will always be bigger than 1. If I were to have a reduction, the image or the new picture now becomes smaller. Okay, so that means I need to be multiplying something that makes it smaller. So in this case, the reduction will definitely have a scale factor that is small, that is smaller than 1. What if the scale factor is 1? Well, we'll get back the exact same shape. Moving on, let's do some drawings. Drawing an enlargement or reduction using scale factor. Draw an enlargement of this triangle using a scale factor of 3. This is an enlargement, so it becomes from the small image to a bigger image. So if I have a bigger one, that means I'm going to multiply by 3 to all the terms, all the different lengths inside. Now let's start with one particular point. And for this case, since the line is diagonal, we're going to count horizontally. There's a horizontal of 4 squares. So let's mark a starting point. 4 squares horizontally times 3 will give us 12 squares. And now I'm shifting down by 1 unit over here. So this will have 1, 2, 3 units. So from this one, there will be one more corner point. And we can try to draw the corner point. Okay, using if you have a ruler, draw using a ruler. And the next one, we shall have the base here. That's 3 squares. So 3 times 3 will give me 9. So I'm going to shift diagonally down to this particular point over here. And then now I have my 3 corners of the triangle. I shall try to complete the diagram. Have you gotten the answer? Draw on the grid an enlargement of a scale factor 3 over 2. So this is going to be enlarged. We're going to multiply by a scale factor that is large. So this is 3 over 2 to the shape times 3 over 2. Let's start with a corner. Okay, one particular point. There is a square of 2 vertical upright squares. So we'll take 2 times 3 over 2 to give us the number 3. So we'll start from the corner over here and we'll draw 1, 2, 3, 3 squares up. Similarly, horizontal one, we will have also 1, 2. So this will be 2 times 3, 1, 2, 3, 3 squares at the other corner. Now we're going to move upwards. So there is a square of 1. So I'm going to take 1 times 3 over 2. That gives me 1.5. So 1.5 square. So I'm going to draw 1.5. So somewhere around here. And draw my straight line. And the next one over at the other side will have also a red color, 3 squares. Oh no, 1 small square. So it would be 1 times 1 times 3 over 2, 1.5. So I have a point somewhere over here. Now I can draw my line. And then that means the rest of the other two will look similar. So I'll have a 1.5 squares. Have you gotten the answer? Practice 2. Now you notice that these two figures are similar. In similar figures, the length changes, but the angle itself does not change. Stays the same. The angle stays the same. It does not change. So therefore, what can we know about the angle over here? If this is 50, that means this angle here stays the same. It's also 50 degrees. Now in the figure, B is a reduction of figure A. Reduction meaning the scale factor will make the diagram change from something that is big to something that is small. Part A, find the scale factor. Scale factor is given by the length of the image over the length of the original. Now the image. What is the image? Is it the bigger or the smaller one? It's actually the smaller one because there's a reduction. So let's find a corresponding pair of values. Length on our diagram. The smaller one has a 3.6 and it corresponds to 9. So I'm going to take the small length, divide by the larger length, and my scale factor will be 2/5. Next, find the value of m. Now we know the scale factor is 2/5, so m, the corresponding side is 5.5, is now equals to the scale factor 2/5. We can cross multiply this and find the answer. So I will get 5m to be equals to 11, and therefore m will be equals to 11/5. (2.2). Find the angle n. So n, the angle stays the same, n equals to 50. Have you gotten your answers? Next part of the question, in the figure, triangle DBE is an enlargement of ABC. This doesn't sound right. Let's make a change. Triangle ABC is an enlargement of the triangle DBE instead. So A, B, and C corresponds to A, D, B, and E. And we know that AC is 15, DE is 12, AD is 4, BE is 20. Find the scale factor. Now this is an enlargement. So for scale factor, to find the enlargement, we will take the corresponding pair of values. So we know that DE is 12, AC is 15. So the scale factor will be taking the larger, the bigger one, over the smaller one. So that means I will take the corresponding sides, 15 over 12, to give me the answer 5/4. Part B, find the length of BC. How do we find the length of BC? Now we know that BC belongs to the big triangle. The corresponding sides will be BE. Following our scale factor tells us taking the big over the small is 5/4. So the corresponding side BC is the length for the big. Okay, which corresponds to BE. So BC over BE, which is 20, is equals to the scale factor 5/4. Now we can cross multiply and find out the answers to be 4 times BC to be equals to 100, and BC will be equals to 25 cm. We can use this method for fraction to find the answer. Alternatively, we can also use ratios. So small is to big gives you 4 units is to 5 units. The smaller length is 20. So how do we find the bigger length? So 20 divided by 4 times 5. That will give me 25 cm. Next part, part C, we're going to find the length of BD. Now BD is a length over here. BD corresponds to AB. But I do not know what is BD. So maybe I shall let BD be X. And it corresponds to the side AB. If this is X and this is 4 over here, what is the whole of AB? That will be X plus 4. According to my scale factor, the large over the small, which is 5 over 4, is equals to taking the large side, which is going to be my AB, X plus 4, over the smaller side, BD, which is X. Using a cross multiplication, we can get this to be equal sign, 5x to be equals to 4 times x plus 4. So 5x equals to 4x plus 16. Simplifying our answer, I will get x to be equals to 16. Have you gotten the answer? The diagram shows the floor plan of the bathroom drawn using a scale 1:40. So the dimensions in the bathroom is drawn to the map scale, map and actual, 1 cm is to 40 cm. So the dimensions in the plan are 6 cm by 5 cm. So 1 cm is equals to 40 cm. They want the actual dimensions in meters. So we're going to change 40 cm to meters. So that will be how much of a meter? We're going to divide by 100 and we'll get 0.4 meters. So 6 cm will now be 6 times 0.4, 2.4 meters. And what about 5 cm? 5 times 0.4, 2 meters. So the actual dimensions of the bathroom are 2.4 meters by 2 meters. Next, find the area of the bathroom in square meters. So map and actual is 1:40. Before I begin, the area will be 6 times 5, 30 cm square. So for map and actual, I have 1:40. 1 cm is to 40 cm. Now they want the meters, so we should change the units into 1 cm is to 0.4 meters. To get the area will be 1 square cm square, 0.4 square meters square. We're going to square everything. And we have 30 cm square, so we're going to take 30 times 0.4 square, and we'll get the answer to be 4.8 meters square. Have you gotten the answer? We've come to the end of this part of the chapter, but we'll be drawing more of the diagrams and answering skill drawing questions through the questions in your textbook. So for the next lesson, you'll need to use your textbooks. Now, see you for the next lesson.